Hi, this is the last video. I'll do two little slightly more difficult questions on trig, just to get you thinking, and yeah, that's the end of the graph booklet. So this question is asking us about a swing set. So these would be the kind of members that support the swing. So if you imagine maybe the kind of wire would be here and the little seat would be here, and it would go backwards and forwards, something like that. And we're asked if this angle is safe. It should be between 63 and 65. So the minute you see angles and you see triangles, you should be thinking of trig. If you see triangles with no angles inside them, it could be a Pythagoras question. But if we see an angle, we're thinking trig. So there's our triangle with terribly unstraight lines. Apologies. So first of all, what's the base of this triangle going to be? Well, what's half of 1.9? It's going to be 0.95. So that line in there is 0.95. We don't know this length here. And the height is 2 meters. Okay. And this is the angle that we're concentrating on. So let's label that up. There's the angle that I'm concentrating on. So this is going to be the opposite. This is going to be the adjacent. And this is the hypotenuse. So I know the opposite. And I know the adjacent. So K2. It can't be sine because I don't know hypotenuse. Can't be cos because I don't know hypotenuse. It's 2 because I know the opposite. I know the adjacent. So I can say tan of x is equal to the opposite over hypotenuse. So tan of x is equal to 2 divided by 0.95. So at this point, you could solve this and then do the inverse. I think I'm just going to write, I think to keep it neat, I'm going to say x is equal to tan to the minus 1 of 2 divided by 0.95. Now all that means is shift tan. Okay, this bit here just means shift tan on your calculators. Shift tan of 2 divided by 0.95. And that is equal to 64.6 degrees. So we wanted to get x on its own. We had to get rid of tan. Now it looks like it's tan times x, but it's not really. Tan's a function, so we're doing x and then we're putting it into this machine of sine, cos, or tan, and it spits out a number. So to get rid of this, we have to do the inverse of the function, and that's why we do the inverse of tan. But on your calculator, that's just shift tan. So if I wanted to move cos over, it would be shift cos of this. If I want to move sine over, shift. So the angle is right in the middle of the sweet zone. So I would then say, yes, it is safe, as 64.6 degrees is between 63 and 65. Simple. Now, last time I was going to do this question, I didn't, because I thought we could probably use Pythagoras on this. But this is actually a really good opportunity to chat about trig. So, a new regulation states the gradient of all ramps must be less than 0.26, and then it gives us a triangle. Does it satisfy the new regulation? So it's saying that the gradient has to be 0.26, and we put these two lengths. So, I mean, the first thing you could do, you could use Pythagoras to work out this length if you wanted. But let's have a think about what the 0.26 means. So we know that a gradient is the opposite over adjacent. Okay, it's how much you go up by how far you go. So if you go up a very far distance, but not along very far, it's a very steep gradient, isn't it? Because your opposite is very big and your adjacent is very small. If it's a shallow gradient, the number is small because you're not going up very high, but you're traveling quite a long way away. Okay, so this would be steep, and this would be shallow. So the bigger the number, the steeper the value. Now they've said that the gradient is 0.26. So what does that actually then mean? Well, if you think about it like that, opposite over adjacent is equal to 0.26. They've actually told us that opposite over adjacent is equal to 0.26. So we could write out, we could say, well, tan of this angle is equal to 0.26. So actually can help us out a little bit. Instead of giving us an opposite and an adjacent, and you could have if you wanted, you could work out this opposite. But they've said, we want this to be our ratio, this is our opposite over adjacent. And then you've got to make the leap to say, well, that's actually, you've told us what tan of x equals. So then I just do shift tan to the -1 of 0.26, and that's going to tell us the safe angle that we can work with. So shift tan 0.26, that's 14.57 degrees. So that's the safe angle. That's the maximum. So you say it must be less than, so that's the maximum angle that we can go to. So let's try and compare our actual angle to the maximum. Okay, so there's our angle in here. So that's going to be the opposite. That's going to be the adjacent, and that's going to be hypotenuse. So good one. What have I got? I've got an adjacent hypotenuse, so it's going to be cos. So I'll say that cos of x is equal to the adjacent over the hypotenuse, and then just sub it. So cos of my angle is equal to 400 divided by 410. And if I want to get x on its own, I have to do shift cos of 400 divided by 410. Like I said before, that's terrible, sorry. Like I said before, that's the inverse. Cos to the -1 means the inverse. On your calculator, that simply just means cos to the -1. So shift cos, and it's 400 divided by 410. So that's going to give me 12.68 degrees. And then you could say the ramp is safe because 12.68 is less than 14.7. So safe as 12.68 degrees is less than 14.57. You could have also, if you wanted, you could have worked out the O. You could have actually used Pythagoras to work out that O. And then you could have done the ratio. You could have done your own opposite divided by adjacent and then compared that ratio against this ratio. That's another way. That's a nice way of doing it. That's what I was thinking before. I thought I don't want to do a Pythagoras question. So you could have done Pythagoras to work out O, and then just said opposite divided by adjacent. That would have maybe given you 0.23, and then you would have said, well, it's fine because 0.23 is less than 0.26 without even thinking about the angles. I'd say the biggest takeaway from that one is thinking about this the ratios you get, and for gradient, that is the height over the length. It's always tan for the gradient, and that comes up in straight line things quite a lot as well. So that's a really good point. Your ratio there is your opposite over your adjacent. That's why I wanted to do this question. I thought it was quite a nice point to make. So that concludes the National 4 paper for Greif. We'll do the other paper soon. Thanks very much.